Good afternoon, everybody. Welcome to this month's Young Professionals Series webinar with CSI. My name is Matthew Fox. As you see the name on the screen there, I work as the Community Development Manager here at CSI, and I am joined today by my coworker, Caitlin Solomon. Caitlin, if you'd like to introduce yourself.
Hello, yeah, I'm glad you guys were able to take the time to join us this afternoon. I am Kate Solomon. I'm CSI's Marketing and Membership Manager. And today, Matt and I will be moderating part 3 of our 10-part series, Understanding the Project Management Team. And our topic for this month is Understanding the Engineer. Now, if you're unfamiliar with the series, this is a year-long campaign dedicated to bringing basic knowledge about the entire project teams to you AEC professionals. So every month, we're going to invite a panel of guests from either an organization or firm and office that represents a specific member of the project team. You can see our outline on the screen there with Matt's beautiful icons. The first half of today's webinar is going to be reserved for the panel to present how their role fits into the larger project of the built environment. And the second half of the webinar is completely dedicated to you, the audience. It's open entirely to Q&A. So we'll have plenty of time for you to ask today's panel anything you've always wanted to know about engineers that maybe have been afraid to ask. And speaking of panels, we have a great one lined up for you today. And thank you all in advance for volunteering on today's webinar. We have Clay Forrester, PE, who earned his bachelor degree in civil engineering from Texas A&M University and has 14 years experience in engineering, primarily private consultation on transportation projects throughout Texas. Clay switched to the public sector about 2 years ago and is currently Assistant County Engineer Development at Fort Bend County. He supervises permitting, plating, construction, enforcement violations, and geographic information systems. Clay is a past chair of ASCE's Committee on Leadership and Management, past president of the ASCE Houston branch, and past president of Texas A&M's Howdy Club, which sounds quite fun. Austin Lynn has earned his bachelor's degree in chemical engineering from Johns Hopkins University and is a certified quality engineer, or CQE. He previously served as supply chain operation manager for Procter & Gamble's chemical and fragrances manufacturing business. Austin serves in regional and national leadership positions with the American Society for Quality, as well as the National Society for Professional Engineers. In 2013, he was awarded the Feigenbaum Medal by ASQ, which is the Society's top international honor for young quality professionals. And we actually found Austin via his blog. Austin has been an active blogger since 2009 for the NSPE Young Professionals blog, and it's focused on self-directed career development and personal brand equity. He has also earned a 6 Sigma Black Belt by ASQ. Ted Slancer, PE, Lead AP, and CDT, graduated from the University of Portland with a Bachelor's of Science in Mechanical Engineering. Ted is currently a Senior Mechanical Engineer at Interface Engineering. As part of the MEP design team, he's responsible for working with architects to design systems to make building work. His main role is designing the HVAC system based on a calculated analysis, informed decisions, and careful coordination. And for his fun fact, his hobbies include skiing, mountain biking, running, and triathlons, which make me feel very lazy, Ted. And lastly, we're joined by David Furry, PE, CCS, who earned his bachelor's and master's degree in mechanical engineering, as well as a master's degree in civil engineering from Michigan Technological University. He has 43 years of experience in engineering, primarily consulting in water and wastewater industries in Michigan, New York, Oregon, Alaska, Colorado, and Florida. He is currently director of SpecTech at ARCOM. And before we get to our esteemed panel here today, we have just a few housekeeping notes. We would love for you to participate with us online today during the webinar. I personally will be live tweeting and encourage you to post notes, highlights, comments, and questions on Twitter using hashtag CSIYPS. One of our panelists, Austin, is also on Twitter, and you can follow him at @AustinSLynn. For those of you who do not use Twitter but want to continue the conversation online, we do have a Young Professionals LinkedIn group to which Matt has posted a link, or you can simply search CSI Young Professionals on LinkedIn to find us.
As you've heard the bios, we are going to start with Clay Forrester. So Clay, the question I'm going to ask you as well as your other panelists to kind of start off today's session is kind of a basic question, just from your point of view, how you got to kind of where you are in the profession, any interesting background you got that led to where you are in the engineering side that you worked in. Many people always just use the word engineer, but there are many different, very specific focuses within engineering. So if you'd like to share a little bit about that, give you 3 to 5 minutes here to kind of just talk a very basic introduction to both yourself, the work you're doing, and your involvement into the overall project team that you may have done in the past. So Clay, I'll leave that question to you. I will mute my line and let you keep going with the conversation.
Well, great. Well, thank you all for having me today. My experience is fairly varied. I graduated from Texas A&M, and then I went straight into the consulting industry as an engineering training, primarily working on transportation projects, anywhere from small local streets all the way up to eventually freeways and interchanges, and then all of the items that go along with that, be it signs and striping or drainage or traffic control for construction sequencing. And so I got some pretty good experience there. Did that for about 5.5 years. I got my professional engineering license, which in the civil engineering industry in particular is extremely important just because of the nature of the work that we do. And then I decided on a change of pace, and I actually went into technical sales, and I was the bridge rep for a national firm here in Houston, and did that for a little over a year. There were some organizational changes that eventually had me looking for another change of pace, and so I managed to get back into consulting. And fortunately for me, because my technical sales experience was so technical in nature, I really didn't lose any of the edge that I needed for consulting and for design. But I had gained a wealth of business experience, so I was able to understand how projects' budgets work, and I was able to talk to people much better because part of the nature of technical sales is interacting with people. So I was able to understand much more about the business end of consulting, and that helped me out greatly for the next 6 or so years that I was in consulting. I finally, here a couple of years ago, decided to make another change and switched over to the government sector. My first stop, I've actually had 2 stops in government. My first stop was actually in charge of in-house design for Harris County. I had a staff of about 25, and it was very nice. I had architects, I had mechanical, electrical engineers, I had some civil engineers, I had some construction managers, I had a variety of different types of staff. But fortunately, my history with managing different types of projects and having some experience in sales enabled me to understand the process of how a project starts at the beginning and goes through to the end. So even though my staff were working on different types of projects in disciplines that I may never have been exposed to, I was still able to understand how it gets from A to Z and give them very, very good and effective guidance to improve the production of our shop. Now I'm at Fort Bend County. I'm the Assistant County Engineer in charge of development, which that entails, for anybody who's familiar with a plat, it's basically a recordation instrument for property. If you want to buy or sell a piece of property in Texas or subdivide it, in Fort Bend County you have to get a plat. That also includes plan review and any kind of permitting. I also have our development projects. Say a private industry wants to come in and develop a piece of property, turn it into a subdivision, 300 homes. Well, they're going to build all the streets that go along with that, and that infrastructure eventually the county will accept. So that's why we have take a review of that and make sure everything meets our criteria. Eventually we accept it into our maintenance system. And so on this end of it, I have staff that I deal with on a regular basis. We deal with the public all the time, anywhere from it could be a landowner that just wants to build a house, all the way to a national or international developer that wants to bring something big to our county. And so I interact with all different types of people, but I still have that fundamental understanding of my engineering background that aids me in making good decisions. that's most of my spiel.
Great. I'm going to just wrap up a couple last-minute comments here. If, Clay, you want to focus just a little bit more, I guess, with your background and how you've connected it to where you've gotten. If you could just, I think we did it a little bit in the introduction, just clarify for the audience what specific engineering you originally went into that may have led you down this path.
Sure. Yeah, my original background was in civil engineering with a focus on transportation. And so what that really is infrastructure projects, municipalities and counties, DOTs, and anywhere from small local streets all the way up to the big freeway corridors. And I had a boss once that told me that every major project, these big mega projects, are really just a series of smaller projects all up together, and if you organize them correctly, you can manage any size project, and I found that to be very good advice.
Great, thank you. I'm going to put that here as one of the notes on the screen before we move on to our next speaker. So thank you again, Clay, as we kind of get your introduction here. And Austin, just a heads up, you're about to come up here as I finish typing this last line. So Austin, as we move to the next slide, we heard his introduction from Caitlin, comes to us from a very different point of view, I guess, of what you look at for engineering. So Austin, I guess same question to you. Your kind of your history into the industry, what kind of engineering you initially studied for, and how that led to where you are now as a person talking to a bunch of people from CSI about project team. So Austin, over to you.
Great. Yeah, thanks. I wanted to take the chance to talk a little bit more about engineering more broadly as a set of career development decisions, whether you work in a private firm or in a government municipality, or if, like me, you ended up in industry. So after college, as I majored in chemical engineering, and then actually most of my close buddies from college went off, continued into academia, the master's, PhD track. For me, one, I was a little burned out already from the chemi curriculum, and secondly, deciding that I didn't want to live for the next 2 or 3 years eating exclusively ramen noodles, I decided to dive into industry, and that's when I joined Procter & Gamble. I started off in the Duracell batteries division and did a lot of hands-on work in battery assembly lines, high-speed assembly, and that was kind of a cool way of blending chemical engineering kind of principles on a more industrial scale. And the other great thing about industry is it got me a lot of upfront kind of trial by fire exposure to the larger aspect of the business world from a more global transactional perspective. We would have customers that we would be delivering millions of cells to domestically in the U.S. As well as overseas, and understanding how the supply chain logistics of all of that connected was really, really eye-opening and very educational for me. So my career as an engineer, specifically, as I said, goes from industry and changed throughout within P&G, and then I left. I've gone through kind of manufacturing, global supply chain work, and then just recently moved from New York City to San Francisco to join the tech industry. So it's quite a wide variety of things, and the one common theme has definitely been the type of work that engineering kind of offers to you. I was excited to hear Clay earlier talk about the PE license. It's actually a really important designation, and as he was saying, the EIT, which is the first part of engineering licensure, and then ultimately the professional engineering licensure, which you take as your license after a few years. It's really important for professional growth, and it's actually a great kind of distinguisher mark for you, even if you do not work in an area that requires the PE license. And if you don't have much background on PE license, just to sketch it out, like if you want to be a lawyer, you go to law school and you get your JD degree, but you still can't practice law until you pass the bar exam for the state in which to practice. Same thing if you're a doctor, you can go to med school, get your MD, but still you can't practice medicine until you pass the appropriate board exam, again in the state that you wish to practice as a doctor. And the PE license is very analogous to that. So to have that PE designation means you can practice as an engineer in the state that you are doing your specific skill in. And you would take a PE exam specific to your level of skill, your skill set. So it's mechanical, civil, structural, chemical, and then even though the PE exam itself is not discipline specific, you take a discipline specific exam and then practice in that area, particularly in those areas that require it. The areas that require it is all 50 states in the U.S. require that license if you work in an area, particularly in government-regulated industries, that can be extrapolated to have a direct impact on public health, safety, and well-being. The work we do at National Society of Professional Engineers, as well as Clay's group, ASCE, do a lot of emphasis on how to connect the dots between having those professional practice capabilities as well as applying that to your real life job. One thing to distinguish between that and a few other things is really it focuses on the practical application. So I have some certifications as well, but I did want to call out, because it's confusing sometimes, the certification versus the licensure aspects of it. Certification, more classically, we think of knowledge-based, and professionally, you think of, for a professional license, the actual practical skills for public safety and well-being. So one of my, I guess, the most beneficial things for me as an engineer working among different project teams, particularly in industry, is really on the career development side. It really gives you a skill set that enables people with engineering backgrounds. You naturally tend to start to think very analytically about things. And as you go through and as you've finished your engineering education or in your first couple of years working as an engineer out in the world, you'll find that engineering really it's not just that diploma on the wall, it's a way of thinking, right? And it's how you look at problems technically, but also organizationally. And so it's a great way to expand your leadership capabilities as well. Getting a chance to work in project teams is a great way for engineers to apply those same analytical skills and technological skills into a more broad leadership, working in cross-functional teams, seeing how the data you provide matches what the larger business implications are for the project, how all of those moving parts fit together, all add up to a really great opportunity for personal career development. And societies like NSPE and ASCE are great forums for you to essentially get that leadership practice and really prep you for when those moments open up in your respective firm or company, that you will have had some time running a committee meeting, running really important legs of a project team, or coordinating across people with different engineering backgrounds or different functional backgrounds altogether. So the development tool itself is a really kind of strong momentum generator.
Great. Well, thank you, Austin. I hope I've caught most of those things in the notes on the screen here, at least in some part. But I'm going to stop you at that point, and move on to bringing in Ted into the conversation so that we can continue with the same question from yet another point of view. So Ted, hopefully you see your profile photo here on the screen. But Ted, I ask you the same thing, 3 to 5 minutes or so, about your background and where you got to where you are working with project teams from your specific interest in the engineering field. So Ted, over to you.
Yeah, thank you. And thanks for having me. This is a little something different for me. But yeah, I started out graduating from University of Portland in mechanical engineering in 2007. And when I started looking at careers, a lot of my friends, my classmates were, looking at kind of more of the heavy industries, and that's kind of where mechanical engineering kind of steers you, designing widgets, working for big companies, designing machines. There's a big company in Seattle that makes airplanes. You might have heard of them, and they gobble up a lot of engineers in the area. And so that's kind of where most mechanical engineering grads are steered towards. But I could tell pretty early on that I wanted something a little different. I worked as an intern at a foundry that designing cast parts And I enjoyed it. I thought it was interesting work, but I knew it was something I wanted for my career. I wanted something a little different. I wanted to feel kind of more of a connection to my community. I wanted to work for a small company. I wanted to get some kind of variety and diversity in projects and material, and not just focus on designing one thing for a whole career. So I found that in this industry. I started working at Interface Engineering. It's a small MEP consulting firm, mechanical, electrical, plumbing. And we're about 200 employees. I've been here now almost 8 years and basically never looked back. A lot of my peers have diverse backgrounds. I work with electrical engineers. I work with folks who have technical degrees, associate degrees, and we work together to deliver a product that kind of represents the vision of the architect who hires us to design the systems for the building. And so we work very closely with them to reach a common goal. Like Austin said, and I agree with what he said about getting your PE early on, that it can be a real career booster. And I saw that early on. I actually flew down to California, where they only require 2 years of experience instead of 4, so I could get my PE license as early as possible, and that was definitely worth it. But now, working on these projects, we have kind of a small role in the project. If you look at the overall picture, if you look at what the architect is doing, what the end product is, we focus on the systems. We focus on the heating, ventilation, air conditioning systems, which is what I design, and we design the power systems, lighting, fire sprinkler, fire alarm, plumbing, all these things that, they aren't the first thing you think of when you think of a building, but they are extremely important, and they're important to consider early on in the project design and to consider thoroughly. I've had great experiences with some of our architects. They come to us because they have a vision. They want to achieve something with the building, and they rely on our expertise to come up with something that achieves that goal. So we work with them directly. We provide analysis. We do energy modeling. We look at sustainability, life cycle costs, and we go through all these exercises to make good decisions that inform the design, so that in the end we end up with something that meets those overall goals, the vision. What's been exciting for me recently, sustainability has really taken off in the course of my career in the last 8 years, and it's really kind of up the ante for what's expected of us. That really put a lot of emphasis on a lot of energy design and analysis, and looking at kind of thinking outside the box. Like, okay, we've designed HVAC systems the same way for 30 years. Why don't we do something different that maybe it's a little more expensive up front, but it saves energy across the long run. So that's kind of more the exciting end of recent developments. And that's also, the sustainable technology is also kind of helped out with realizing the architect's vision. For instance, we're looking at things like radiant slabs. We can heat and cool a building just by running hot and cold water through the floor slab. And this has allowed things like taller ceilings, less ductwork in the buildings, which, allows for a more aesthetically pleasing building. And so that's exciting. But I got to say, the best part of what we do is when we design something on paper, we go through all the hoops and figure out the best design approach. And the best thing is when we get out on site and see it built, and we see it working, we see it in place. That's when you realize that all your blood, sweat, and tears and everything that's gone into the drawings and specs is now working, and it exists as a real thing. So that's kind of a summary of where I started and now where I am now.
Great. Well, thank you, Ted. So hopefully, again, I've gotten some notes on the screen here that relate to summarizing a little bit about everything you've talked there as we get into more conversation and questions shortly. So lastly, to bring up the end of our panel discussion, we have David. So David, again, you by now already know the question I'm going to ask you, but to start us off, if you want to just walk us through a little bit about where you started and how you got to where you are in the profession and, how it is that you work within a project team in one way or another. So David, over to you.
Okay, thank you, Matt, and thanks to everybody who's tuning in today. I think from what I gather, I'm probably one of the older people attending this webinar. When I got out of school, actually my undergraduate degree in mechanical engineering, I went through the entire 4 years with a slide rule. Shows you how far back that was. It's interesting because I went back a few years later for a master's in civil engineering, and calculators were just coming into play. Matter of fact, I had to mail order one. And then 10 years later, I went back for a master's in mechanical engineering, and computers were the hot topic. So I call it my hat trick. Slide rules, calculators, and then computers. Anyways, when I got out of mechanical engineering for various reasons, my background was primarily heat transfer and thermodynamics. I took a job with a steel mill in the Detroit area, and I very soon found out that I wasn't really fitting in there, and it just didn't appeal to me. And I think that's the first word of advice I've got, or something to consider, is a lot of the time having jobs allows you to find out what you don't want to do rather than what you do want to do. And I think it's almost, if not equally important, to realize those. I went back for the civil degree because I wanted to be out of factories. I had my fill of factories at that point. And concentrated in the water wastewater area. Worked for consulting firms that I started to work for consulting firms, and eventually made my way up to Alaska. And Alaska was a great place. I'm sure it still is. I haven't been up there in a while, but in most firms that I've been associated with, if you're a young person, you've got about 4 levels of people above you to get to the job that you ultimately desire. Up in Alaska, you see 28-year-old people being bank presidents, probably due to the lack of people up there applying for the jobs. But it was a wonderful opportunity for me, and I got involved in a little bit of everything all at once. Not just the technical aspect of things, which is my forte, but also into the project management and marketing aspects, which I will admit that I really don't fall into that. I'm more of a technical person. I always was, but from time to time you have to put on the hat of a project manager and a marketer, and I've been able to carry that through. Right after Alaska, I had a kind of a midlife crisis. I was in my 30s at that point, and always wanted to teach school. So I took a hiatus from engineering, went back for the master's in mechanical engineering because I wanted to sharpen up my math and my heat transfer skills. And at the same time, I got a secondary science in math certification, and I actually taught high school for a year in northern Wisconsin, which was fun. the heat transfer really and the civil really combined together wonderfully up in Alaska because they have a program up there called Arctic Engineering, and it involves some heavy-duty heat transfer, more practical heat transfer than the theoretical that I had, while getting my first degree, and I really enjoyed that. I soon found out, besides the technical aspect of things, that I was one of the few engineers who could write. And I ended up getting all the reports and studies, either to do them myself or to edit and review other people's work, which I think kind of led me into specification writing. I'd like to say, and there are exceptions, there are probably a lot of exceptions in the audience today, that engineers as a whole cannot write, in my opinion. And so if you find an engineer who can put, a couple of nouns and verbs together properly, it goes a long way. If a person wants to move in that area, there are a lot of opportunities for a technical person who can also write. Which led me, the last consulting firm I worked for, about 5 or 6 years ago, I left them. I was the chief specifications writer, and for a pretty good-sized firm, multinational firm. And then I joined Spectex, which is owned by Arcom. Arcom also does master spec, which some of you are probably more familiar with, especially the architects. A few years ago, they purchased Spectex, and they needed somebody who knew spec writing and also had wastewater process experience to build up their specification libraries, and I've been there ever since. And just in closing, I'd like to emphasize again and make it unanimous about the PE license. Extremely important, and it really does open up a lot of doors. Or you could look at it and say that a lot of doors are closed unless you have those credentials. And I think that's about it. Back to you, Matt.
Great. Well, thank you very much, David. So hopefully now everybody in the audience has had some time to get to know our panelists a little bit more and maybe get some juices flowing for questions you might want to ask. So far, it looks like the audience has been quiet. Caitlin, have you gotten anything from Twitter before I jump into a few questions I have?
Appreciate the people joining us online today. I also have a couple questions, Matt. One is you guys kind of started talking, and I appreciate you each mentioning the importance of the project team. Whole purpose of this Young Professional series, of course, is to make sure you know the other roles you're working with. But when you all started out, the whole idea of an integrated system really hadn't been, I feel like, is almost a new trendy thing to happen. When you started out, how did you learn about the other roles of the project team, since Matt and I weren't putting on these webinars yet?
Yeah, this is Dave. The way I found out was by just observing. I got into a cubbyhole. I started out in the consulting business doing flood insurance studies, where you do hydraulic analysis of rivers to determine flood stage. And that's not what I really wanted to do, and I was just doing that. And after a few months, I started asking around and finding more interesting things to do and talking to people at this firm, and finally got invited to join in some other projects. And I left flood insurance studies in the dust and started moving on from there. And it's just a matter of, I guess the correct term these days is networking. Letting people know that you're interested and you have an aptitude for something, and next thing you know, you're part of the team. It's been my experience.
Yeah, this is Austin. I definitely agree with that when you kind of find your way in those situations. In industry, very few things are not done in the context of a team. So just about every interaction you have pushes you to work very cross-functionally. Even in a lot of engineering project teams that are even just technologically focused, you're working with a thermal guy, an electrical guy, two structural guys, a couple of manufacturing folks, a quality person. So you kind of by necessity have to pick up those skills. And what's really valuable about working in a project team setting is that early on in your career, you know the environment that you kind of came up in academically and professionally. So you could speak in the chemie language or the mechanical engineering language or the civil language. And then for a while, you'll kind of be stumped and say, well, why don't they get what I'm trying to say? And it's because you have that expertise, and their expertise is in finance or it's in marketing. And David said earlier, you have to interact with the marketing hat and the sales hat and the customer service hat. And all those things is really what comes together to run a business, whether you're a small firm or if you're a large multinational corporation. So those are really important skills, and a lot of those skills you can't really get academically in a practical aspect. A lot of those you get by doing, and there's no better way of doing that than in the context of a multifunctional project team.
And this is Clay. When I first started out, I was very fortunate in my first job in that for the majority of the different types of disciplines we would encounter on our projects, the upper management was very focused on making sure we were exposed to everything. So on a given project, the team might consist of a senior project manager, maybe somebody who had just gotten their PE, and then there might be one or two engineers in training, and then possibly, depending on the project, there might be somebody to do the drafting. But even for us, we were trained to do most of our drafting as we performed the design. The other components that would plug into a team might be other consultants, other firms that were part of the overall project team. And at first, there wasn't a whole lot of exposure to them, but as we were developed into our careers, we were all given a fire hose and told to take a big drink, and they'd give us as much as we could handle. So, with the right amount of initiative, those of us who possessed it could rise to the top and take on more and more, and eventually be groomed into project managers.
Yeah, this is Ted. It seems like there's no shortage of project team members. I feel like I'm still learning about new roles out there, especially on the contractor side. General contractor who hires a mechanical contractor, who hires a test and balance contractor, who hires a controls contractor. There's always new roles, and that we're constantly interacting with. But when you're first starting out, you just kind of start with one piece at a time. Okay, we're going to go meet with the architect. They're the architect, and you go from there, and then you build up your familiarity with all the other specialties out there, whether it's an acoustic consultant or whoever, both on on the consulting side, design, and on the contractor side.
All right, another question for you guys all here. So we started this series off by talking to owners and, them kind of being the starting point for why a project is happening. And then last month we talked to architects, and they talked about how they kind of oversee a lot of the pieces of the puzzle and kind of work along with the client. And then listening to all of you all today as engineers talking similarly about the idea of kind of being project leads in major parts of overall projects. Would love your point of view on, I guess, how you personally or how you see within the industry, you as an engineer fits within, your major point of contact. So do you majorly, do you talk with just the client? Do you talk with the engineers? Because a lot of people in the industry kind of lump AE together. Or do you see it as really being a separate contract really with the owner that goes with different information, goes to different parties? So I'd love your opinion on that, so that we can kind of tie in the last two as well as also building on for the next sessions as well. So whoever would like to handle that question first.
This is Dave once again. I'll just jump in first. Most of my consulting engineering experience was with smaller firms as small as just 2 people, up to maybe 60 or 70. And in that role, you ended up being the client contact person. The project was yours. You had ownership of the project, and dealt with the owners' representatives, as well as the technical people that were involved. With the larger firms, it was a little bit less of that. The large firms, you have career project managers and separate client service managers, that sort of thing. And as an engineer, you kind of delegated only to talking with the technical people, your peers, with the owner's organization, if they even have had anybody in that capacity. Otherwise, you would report up the ladder to your firm. That's one of the things I did not like about very large firms. Smaller firms, there's a lot more intimate and contact, and you get to be friends with these people. Have them over for dinner, or go out to a bar or whatever you like to do, and you would see them. This was especially true again up in Alaska, where it's a relatively small technical community, and everybody knows everybody else through their professional organizations. So it can be a kind of a two-sided fence here.
This is Austin. Most of my background has actually been more on the supplier and vendor side with the project team. So my role was to go work a lot of either engineering capability or technological projects at the vendor end, and ensure that the project team, that the incoming processes, parts, machinery, equipment flowing into the larger team, where we were getting things to specification. And that was an exciting way to kind of expand the scope and see impact of the project work. A lot of the engineering decisions that would be done in the context of the project team would then get relayed back to this larger sort of global supply chain group. And in addition to getting to travel around and see different parts of the world through an engineer's eyes, a lot of that value that you get from that you bring back to the team, and you kind of end up facilitating this dialogue between technological side of things and the business implication of things. Mm-hmm. Cost is very important, and then when you start shipping things, if you purchase a piece of equipment, say from Italy or from Japan, import-export costs, customs, lead times to make it to the project site. These are all additional factors that you otherwise wouldn't get exposed to. So you kind of do a lot of on-the-fly learning that way. That's also really fulfilling.
Yeah, this is Ted. Yeah, I guess when a project starts out, everyone's assigned a role, right? I'm the mechanical engineer. I'm going to design the mechanical system. On paper, the division of roles is very clean, but once you start digging into it, you realize that, well, yeah, I can design the mechanical system, but it has so many interactions and implications with all the other systems in the building. So I have to communicate closely with our, whether that's in-house here with our electrical and plumbing engineers, or if I have to go to the architect and ask for more space in my mechanical room or less space, as the case may be, and so everything's just kind of tied together, and it's important to understand how your small portion of the building interacts with everything else, and that you communicate appropriately to whoever is going to feel the impact of your system.
I think that this is Clay. I think David touched on a good point. That a lot of times the experience that an engineer has with a project can vary dramatically depending on the type of firm, if it's a small firm or a large firm, and the scale of the project. In my industry, in civil engineering, we very rarely had architects even involved with our project. So with the smaller firms, with one where I started, we it was really between us and the owner, and it was a relatively flat organization for the project team. If you needed heavy-duty support on a structural design, we had a structural engineer, but the small stuff you did yourself. And then later in my career, I started to see bigger projects in which I was either a project manager or a deputy project manager. Still in civil, in that part of the industry, architects really weren't involved, but things got so big where you would have a group of 4 or 5 people that did structural design, a group of another 4 or 5 people that did drainage design. And what I really found in that is that whether it is a group that would do surveying, whether it was a group in your company or a group that worked for another firm, as a project manager, you treated them all the same. And it was the key to a successful project versus a project that didn't work out well was the quality of the manager, making sure all the different pieces of all the different team members were able to work together and talk to each other. About the worst thing you can have on a project is when one group over here is off in one direction and another group's off in another direction, and they're part of the same project, and then their work product doesn't fit together.
Yeah, and I think actually tying that together, another question for all of you, especially since we have such a diverse background in the engineering that you started in or that you're currently practicing, as we look forward to next month's topic and the idea of the information manager as the person that, what we've in the past called the specifier, the person that kind of oversees the collection of the written documentation that goes along with the drawing set before it goes out to bid and to be built. There's been many different ways in the iterations, especially as technology has changed, that we've been able to collect that information and solidify that information. And would love your points of view on how each of you works with getting the engineering information as part of the end document set that goes forward, whether it be that you use your information gets put directly into a BIM model, or it gets put into specifications and you work with those information managers directly, or if your drawing set becomes part of the initial design shop drawings and it's combined into a single binder. Would love your input on, within your current day-to-day activities, how you get the engineering information to the next step of a phase.
Okay, Dave, once again, starting out. Right now, I do not do this. As I mentioned, I work for a company that actually develops guide specifications. However, we get calls, from a lot of our clients, and we try to instruct them on the proper way of doing this, and that is to develop, whether it's from guide specs you get from a firm like ours, there are several of them out there that develop guide specs on a subscription basis, or if you work for a bigger firm that has their own library of specs that are updated by chief engineers. The key is to develop, and first of all, a set of office masters. And these office masters are written, edited for your particular clients with your firm. Obviously, you have a global master guide spec. It's going to cover everything, including the kitchen sink, no pun intended. And you need to weed that out. Perhaps your clients prefer a certain type of valve, for instance, or a particular piece of equipment, or a particular manufacturer, for that matter. Then your spec should be fine-tuned for that. And then the individual project engineers have these libraries that will be available to them, where they can then edit it further for their project-specific requirements. And it's pretty much how I dealt with it throughout my consulting firm days, even back 40 years ago. We didn't have computers to do this. We actually had typing pools, if you can believe that. And where you would actually, the cut and paste actually meant cut and paste, where you take scissors and Scotch tape and put specs together. And from there we've come a long way, obviously, but it's the same process that we used years ago. Is still being used today, and that's the tools got a lot more efficient. That's for sure, but it's the same thing.
Yeah, this is Ted. Simply put, our delivery method is through a set of drawings and a set of specs, and that gets combined with the architectural set, the structural set, the civil. All the specialties get combined in one bidding package in the contract documents, which is just drawings and specs. But a lot of the kind of like what David said is our method of how we get there is kind of has changed. We're transitioning into BIM. We're using BIM almost exclusively now as opposed to CAD-based drawings, and so we're working towards a day where maybe we will deliver a project with just a model and deliver that electronically, and then all the bidders can kind of look at that and get their information that way rather than flipping through plans and reading through specs. We're probably a little ways off from that, but that's kind of the future of where things are headed.
From an industry point of view, the engineering from design, drawing to finished product and back again, the iteration cycles are actually quite rapid because we're dealing with either smaller, particularly in consumer goods, a much smaller scale than, say, if you're doing a building or a larger structure or a job site. So one of the key things we look for is when you have the initial technical drawings, we really spend a lot of time looking at the data that validates those either system settings or design dimensions, prototyping very quickly, and having the data to validate that that's in the right direction before we solidify and scale. So the beauty of scale is that you can then expand, particularly in the manufacturing world. Scale is what makes that business model work. But the downside is if you scale an error, it also scales very quickly. So there's a lot of risk mitigation in doing the due diligence in the data validation phases. And that's probably the key driver, the key kind of gatekeeper in getting something from spec into finished product.
All right, well, I have a two-part question for the panelists on the line, and hopefully it'll be a fun one for you. Part one is, what do you wish other members of the project team knew about engineers? And on the other side of that, what's a stereotype you want to break? So feel free to dispel the myth now.
One of the things I think it was Austin referred to a couple times is what I call the engineering mentality, and that is of problem solvers. And that can be obnoxious at times. I go to parties, and most of the time I try to avoid, if I can, introducing myself as an engineer because I think that is a stereotype, and a well-deserved one. A lot of people, a lot of engineers, I should say, get into that mindset and sort of bring the problems onto themselves by not being a know-it-all, but treating everything as if a problem. One of my favorite phrases is, the chief cause of problems are solutions. A lot of times that, you set out to solve a problem that really isn't even a problem, but it's what you do, so you feel compelled to do it. If that makes sense to anybody.
Yeah, I think that's a good point that David was mentioning. I mean, engineering as a perception, it's really two worlds. There's kind of the inner side, what we see ourselves, and how public perceives engineers. And speaking of solutions, it's our problem, but it's also our solutions as engineers. Internally, you're an engineer if the typical person will go to like the CVS or something to buy cough syrup, and they find the brand they like, and then they leave. You can pick out the engineer because they're the one holding like 5 different brands of cough syrup, looking at the ingredients, looking at what percentage of cough syrup it is, what the daily dose is, and your wife or your husband or your spouse will just be like, just frickin' pick a cough syrup. What are you doing? And it takes a long time, and that's what annoys people about us. But at the same time, we're kind of the masters of our own fate, right? To change the public perception of engineers have to be the ones to do that. There's no Save the Engineers advocacy group out there. It's engineers, and so it's coming across as being sociable in a sincere way, and it's coming across as providing that unique view that engineers do get to do in a social, more public setting. So we are our own solution, I think.
Yeah, I think that maybe speaking of a solution, one solution on that is the old saying, keep your eye on the prize. I do think that engineers as an industry or as a profession are very prone to digging down into the weeds and running around in circles. And if you keep your eye on the prize, that starts with identifying what the problem is and then saying what you're going to do to fix it and then delivering something at the end. It's that delivering something at the end that engineers can get off track getting from point A to point B. But, I don't, for what it's worth, this question kind of implies that there are a lot of negative stereotypes about engineers, and personally I don't feel that way. Maybe it's different in civil engineering, but most of the civil engineering profession, I feel there's a strong focus on leadership. There's a strong focus on ownership of your project. By getting your professional engineering license, you assume liability for the product that you deliver, and so the accountability there drives us to, I guess, be out of the box and out of the stereotype a little bit, I guess. Having dealt with lots of different disciplines of engineering and dealing with architects, because quite frankly, by and large, architects and engineers are cats and dogs. There's a lot of reasons for that, but I have had no problem working with architects because I have been able to relate to them. I've asked the kind of questions of what is it you're trying to get out of this? In other words, identify the problem. And then I'm able to come up with different pieces of the solution that we can work on together to get there. So I don't really see the stereotype as many as most. I mean, everybody's seen the guy that sits in the office and you shuffle the papers out of the door and then the answer comes back. But in civil engineering, it's extremely hard to be that stereotype.
Yeah, this is Ted. I work with, if you had to pick a type of engineer, I probably have worked with every type there is, from the very, shut-in type engineer who doesn't want to talk to anybody to the very gregarious and outgoing type. And, our clients, are architects, and, they're creative and they're usually very social, and they kind of look to us. They don't want to work with a boring engineer who's going to sit at meetings and not say anything for 2 hours. They want to work with someone who's going to be social, who's going to be outgoing and vocal and explaining how things are working and what the issues are, and to talk through them together as a group. They want that because that's what they're like, and that's probably the biggest stereotype we see that I try to break, to be outgoing to our clients and communicate clearly.
And this is Clay again. If we engineers want to break the stereotype, and this kind of rolls into any advice I could give any of the young professionals listening to this webinar, I would highly recommend involvement in organizations outside of the workplace. It's the best way to get exposed to other people. It's free leadership and management training in a low-risk environment if you really get involved. And it will help you immensely in your workplace in not only understanding how to herd cats, for lack of a better phrase, but just being able to interact with other people. If that helps definitely break that stereotype when you get involved. And organizations outside of the office, like for me, the American Society of Civil Engineers are an outstanding resource Or let's say you're that guy just designing things in little boxes and you want to get to the next level and you want your boss's job. American Civil Engineers has resources and materials that can help you see where you are in your career. In our case, it's career paths in civil engineering. There are all kinds of resources out there that you ought to take advantage of.
I'd like to close on a positive note as well and emphasize what Clay was just mentioning. What I've done, and you couldn't have told me this when I was in my 20s, but most engineers, again, stereotype, absolutely abhorred their humanities classes back in college, the ones you had to take. I found out by reading and exploring some of the arts over time, and I really started enjoying it and kind of expanded on that. It's just, I guess my advice is to look beyond engineering and problem solving to some non-tangible things and find something of interest, general interest, rather than technical. That's it.
This is Austin. I really couldn't agree with Clay more, and kind of the things that Dave was just saying about expanding and kind of pushing yourself to skill sets beyond the technical skills. All of those kind of come together in how you communicate and kind of promote your personal brand in the workplace. And there's really no better way to practice that than in a professional organization, even if whether it's a technical one or not. In those forums, you still get the knowledge setting that helps your career in a technical way, but it's how do you have those hallway conversations? How do you have when you run into people you haven't seen in a few years, or you meet someone essentially you've never met before, but is essentially your counterpart at another firm. And through that, you gain a lot of great expertise and mentors and allies who kind of know what you're living through from a day-to-day standpoint, whether from an engineering standpoint or from a business or marketing or finance standpoint, but from a completely different company, from a completely different viewpoint. And those really add up to contributing to your overall growth. So professional organizations are a great way to continue expanding those areas.
Matt, do you see any other questions for our panelists today? Matt, did we lose you, or do you have yourself on mute?
Oh, so it looks like I just got a question in here from Tom that I'm going to ask here. As someone who works for a manufacturer, what are important qualities, performance, environmental impact, etc., that you look at for products you use on projects? And I think also tying that into a question we had last month might be a good way to wrap up today's session. So answering the question from Tom, which I'll type on the screen in a second, and also on that, when looking at products or looking for products, we asked the question last month of architects, and we'll ask it this month. How do you like to find out that information? Do you like product rep and sales rep people to reach out to you? Is it something where you prefer to find that information yourself through word of mouth or through internet and then reach out to the product reps? Or what is the process in which you'd like to be able to investigate that? I think, Austin, you might have a very different point of view on this than the other engineers on the call. But I'll type Tom's question into the area, and whoever would like to get started with that, we'll wrap that up with today's question for the end of today's session.
Is it how products is done with? I heard something about environmental impact of those decisions, or how in general we come across making product decisions.
The question was really stressing what are the important qualities you're looking for products used on projects, and the example, of course, was environmental impact or performance.
Okay. So just speaking from industry's point of view, a lot of companies now have, so the older model, say 20, 30 years ago, and still lots of remnants, is what else beyond cost can designate whether there is long-term sustainability or reliability for a given raw material or product choice. And it's kind of a combination of doing a lot of research, given the resources you have at hand, doing research, whether it's trade shows or those types of things. That's more a traditional way. Having the sales guys come to your group and kind of show you products, that's helpful in some regards because you get a wider exposure. I think it's really defined, that goes back to the product definition itself. And if you say, here are the success criteria for this project, and what are the things that I am using in, and again, to use a manufacturing example, what are the raw materials that I need to, what are the bare physical requirements of the raw material that will give me this result? And then you look at, all right, well, if here's what's off the shelf today, are there other alternative solutions that can support that in a much more environmentally or sustainable, impactful way, in a positive way, that can also deliver those same success criteria. And in a perfect world, then you would look for, really, a lot of teams now are bringing those into the forefront where you're getting a lot of the sustainability as part of the design phase, whereas it used to be done much closer towards the end in traditional manufacturing. And that's really what's made the big difference. Those are new variables now. They're not features that you add at the end of the project. They're required variables at the very beginning, at the design phase. And that facilitates the product selection a lot more.
Mm-hmm. As I recall, to address this question, what we used to do was, first of all, number one was to get client preferences, if they've used something before or some type of device or material before. Then we would obviously go with their preferences. Other than that, it would be a team discussion on, and obviously things we look at where it would be like quality and brand name, that sort of thing. There are a lot more pieces of equipment and pumps, for instance, valves, from all over the world, and one has to be very selective in what they pick. And another problem here is the change. You might be familiar with a particular manufacturer or brand, and when you did a project 3 years ago, and now you look them up, and they've been bought and sold by 3 different companies, and there's no telling if they're even in existence anymore. But typically, in my experience, the engineers I've worked with pretty much stay with the same brands that they've had experience with. And we're very conservative and not very likely to be too innovative. As far as sustainability, environmental impact goes, that's always a concern for everybody. But a little less so, less emphasis in the process industry, where you're picking the most efficient pump to begin with, and you're not concerned with things like building insulation and different lead oriented things, or environmental sustainability items. So that's my 2 cents.
This is Clay. If it depends on the project. Generally, the types of projects that we work on in my particular industry tend to be publicly bid projects. If you have a very unique product, it can be very difficult if there aren't competitors for that project available on the market. But in limited circumstances, we can try new things, or go outside the box. The things that I'm looking for, first, I need it to be easy for a contractor that may not be familiar with the product to install. That's just critical. If a public bid contractor can't install it, it's going to be reflected in their bid price, and the product is never going to make it that far. Also, I'd like to know, what is the cost up front? What is the cost over the long term? Spending more money on a pipe product, for example, that isn't going to have a longer lifespan really is of no benefit to me or to taxpayers of of Fort Bend County. And so I'm looking at costs, not only material costs, but installation costs. I want to know if it's a relatively new product. I still want to know that it's proven. I'd like to see testing, material testing, or examples of other installations where it's been successful. And I'd like to see examples of installations where it hasn't been, because that helps prove to me that you understand the limitations of your product. If you come in to me and say it's just a cure-all, I'm not going to believe you, and I'm not likely to use your product. As far as the best way to approach me, cold calling's not it. I have 8 million things to do, as does everybody that sits in an office. The best way to approach me or a lot of the folks in my industry, take a look at projects that have publicly bid using products where you think what you have to offer may be a fit. And then you can come to me and say, hey, I saw this project. I might have a few things here that I think could be of value to you. And then I'm willing to listen. I might be willing to sit down and take a look at what you have, ask some hard questions, and then maybe we can take it from there. But just send me stuff in the mail or shoot me emails or phone calls. No, it needs to be tied to some type of context that proves to me that you have some kind of benefit in order for me to continue looking at it.
Yeah, this is Ted. Probably one of the most valuable opportunities we have to learn about new products is through lunch and learns here in our office. We have pretty good relationships with all of our reps in the local area, and they'll come in every now and then, just give us an update on what products they're repping, what's new, new innovations, or just an update on the products we're used to using. And getting refreshers on that. So that's pretty good for getting kind of just a general overview of what's out there, what's changing, because the products are changing very rapidly in our industry, and it's important to keep up with those changes. And then when I'm starting up a project, sometimes a light bulb will go off like, hey, I remember this product from way back that it would be a good application for this project, and I'll call my rep and kind of follow up and get more detailed information. Like, hey, I think I remember you presented on something that would do this. Could you give me more info on that? And so those lunch and learns are a good kind of starting point, just to give you an idea of what's out there. And that also helps us. I agree with what Clay was saying about making sure you have you're not just flat specking one product, that you're doing the research to understand that if you want a certain product, that you also have equivalent manufacturers that can provide a similar product competitively, so you get the best price on the project, and that's going to be best for the owner. As far as environmental impact goes, we certainly consider that. LEED has a credit for regional materials and like adhesives. It kind of applies more to the architectural side in terms of where you get your wood, what kind of adhesives you use in the carpet. It's usually not MEP related, so that doesn't have a big impact on us. But certainly, like something like refrigerant, for instance, where we've seen some of the old refrigerants that deplete the ozone have been phased out, and so we make sure that we get equipment that doesn't have those old refrigerants and has only the new environmentally friendly refrigerants. So stuff to look out for.
Well, thank you all. I hope that answered Tom's question. If you have any other questions, feel free to ask them on Twitter or, again, on our LinkedIn group. I know our panelists have graciously stayed a few extra minutes to thank you all on the line, but everyone obviously has very important jobs to do. So, Matt, why don't you close us out?
All right. Well, thank you again to all 4 of our panelists today. And again, thank you to Caitlin and to our audience members that attended today's session. As you can see on the screen here again, feel free to contact us. Both Caitlin and I's emails as well as Twitter accounts are on the screen there. Additionally, you see on the bottom the 2 web pages that may be helpful to you, both CSI's homepage as well as CSI's Young Professional Series microsite with just content related specific to this series of sessions. So feel free to check that out whenever you get a chance. Again, reminder to everybody, today's recording will be on the YouTube channel sometime in the next week or two, so keep an eye out for that if you'd like to go back and revisit any of today's content. But as you see here, we do have a session next month. I know this is the time of the season with all the different winter holidays that make meetings a little bit difficult, but also sometimes a little bit quiet in the office, so you may be able to have time to attend another session. So we look forward to hopefully having you all on our December 18th call. Again, that's the third Thursday of the month, and look for that again from 2 to 3 p.m. Eastern Time, as we'll be going through the next part of this phase, as you saw earlier in the session, but we'll be talking to information managers, so both specifiers and people that may be working into the BIM information side of things. So we'll get a couple of panelists again to address some of your questions, as well as introduce us a little bit more to what they actually do within the project team. So we would look forward to having all of you on that session. And again, thank you to Clay, Austin, Ted, and David for your time and your great insight and helpful information on the world of the engineer within the project team. So with that, any questions you have, again, please direct them to our LinkedIn group or to our Twitter account, and we look forward to seeing all of you at a future session. Thanks, everyone. Have a good day.